We're going to be working on mass problems right now. So we'll be working on the back side of the worksheet we just finished up. We just worked on a few minutes ago the mole paper, getting all the conversions. And we'll be using part of this in our conversions we're doing now. Up to now, let's see, on our gram formula mass paper, our review sheet, we've practiced going from grams to moles, which on our paper here, we went from grams to moles by multiplying, and that's, by dividing, and that's what we did right here. Then on the second part of this sheet, we went from moles to grams, and we were multiplying, and when you go from moles to grams, multiply just like I showed you on here. So now we're going to be doing a three-step conversion that's going to be using part of that, the mole to grams, the grams to mole, and the mole. Sounds kind of complicated, but it's not if you follow the methodology that I've been showing you how to do. So let's turn this over. There we go. So this is our problem sheet. Okay. Get this bigger and better for you. Okay. Right there. Take this down so it doesn't move and shift. So in this problem, how many grams of potassium chloride are produced if 61.5 grams of potassium chlorate decompose? Well, in our problem, our given is 61.5. That's what we're asked to convert, and we want to find how many grams of potassium chlorate. So grams, KCl, potassium chloride, grams of potassium chloride, KCl. So that's what we're ultimately looking for. So as usual, we're going to start off with what's given. We're given 61.5 grams of potassium chlorate. Now, this is where, in these types of problems, this is where it's so important that you put grams and KClO3, because we're going to be doing lots of cross-canceling. Set up our multiplication conversion chart here. So now, what we need to do is convert the grams of potassium chlorate into moles. And we look on our chart, and here's potassium chlorate. We know we've already calculated that the molar mass is 122 grams per mole. So we'll put 122 grams KClO3 in 1 mole. KClO3. Wait a moment, let you get those written. Grams KClO3 cancel, as these do right here. So what we've done, we've converted the grams into moles, but we're not done. Now we're going to have to do the mole ratios like we just practiced before, and we just take a look up here and look at the moles in our balanced equation. So since we want to get rid of moles potassium chlorate, we look up here, there's two, in this balance of reaction, there's 2 moles of potassium chlorate. So we're going to put 2 moles KClO3. And we're looking for potassium chloride. And for every 2 potassium chlorates, we will get 2 potassium chlorides. So there's our ratio. 2 to 2. KCl. Oh, I left off. Let's put mole in there. Moles of potassium chlorate. So now we're in the process of converting potassium chlorate into potassium chloride. Keep misstating that. I got to make sure to get it right. Now, I know what you're saying. You're going, hey, that's a 1-to-1 ratio. Yeah, it is. So we can just right now cancel out these. They just become 1 to 1. We can also cancel out moles potassium chlorate. Moles potassium chlorate. So now in this 2-step process so far, we've converted 61 grams of potassium chlorate. We know we're going to find out how many moles of potassium chloride we have. Now as we go, let's continue on, because we're not looking for moles of potassium chloride, we're looking for grams of potassium chloride. And we know how to do that. We've done that before in previous problems. So let's get our next problem set up. And we look on our chart here, our reference chart. We've already calculated in previous class that the molar mass for potassium chloride is 74 grams per mole. So let's do 1 mole KCl. And we just said it was what? 74. And that was from looking at our chart that we previously had, 74 grams KCl. And now what we can do, moles potassium chlorate cancels with moles of potassium, moles of potassium chloride cancels with moles of potassium chloride there. So now, what we're left with this problem, we've got 61 times 74, then divide that answer by 122. But wait, look at this. Let's guesstimate. Looking at this, 61.5, looks, that'll go in there about twice. In fact, wait a minute. Look, at 61.5 will go in there, I think, exactly twice. So I'm going to cancel. There's one goes in, 61.5 goes into itself once. It goes in there twice. Look at that. We've just made this problem simpler. So now we've got 1 times 1 times 1 times 74. So just the numbers, we have 74 divided by 2. And those brainiacs out there, come on, you can do it. Okay, 74, gotta get half 14. Okay, all right, you got it. So let's see here. Come on, you can do it. Okay, if you just shouted out 37, you can get a piece of candy out of the Red Cross drawer when you leave. Okay, wait a minute. 37, but that's not the right answer. Grams KCl. KCl, grams KCl. There we go. We've got the correct answer put there. Make sure we did it right. All right. So, there we go. I'd like you to practice setting these up. I'll have you work out this one. Now look it's going to be the same thing when you work on question 2 and 3 and 4 and 5. In fact, your homework for Monday is I want you to have this completed, get it worked out, and you're just going to follow the same methodology. We're doing the same thing. You start off with what's given. In fact, I will help you here. As we read this problem, completely react with, this is our given. So let's just get 56.0 grams of nitrogen. Now when we say nitrogen, it's nitrogen N2 on there. And then we're going to be converting that, and it's just following the same steps we did up here. We're looking for how many grams of hydrogen. That's what we're looking for. I'm going to put a question mark above that. The given 56 grams of nitrogen. So now we're going to follow this. You're going to look at the molar ratios. And over here, our answer should be, again, it's going to be grams of hydrogen. H2 now, when we say grams of hydrogen, it's hydrogen gas, okay? So let's take a look at number 3. We can get these pre-set up, because if you just take them step by step, they shouldn't be too tough. How many grams of ammonia are produced in the reaction from problem 2? So we're looking at problem 2. So we're looking for how many grams of ammonia are produced. So now it's going to be grams NH3, and I'm sorry, NH3. That's what we're looking for. How many grams of ammonia will be produced? Now, the given in this problem, they didn't tell us the given, but we'll start right over here. The given in this problem is going to be, well, it can start with grams of H2. In fact, so whatever the grams is you calculated here, that becomes your given over here. Given. So then in this problem, you'll be comparing the hydrogen to ammonia, and we got a 3:2 ratio there. That'll be your ratio in the middle. So the answer to problem 2 becomes the given in problem 3. Okay, we take a look at this double displacement reaction, and as we read through, how many grams of silver chloride are produced? Okay, so we're looking for grams AgCl, that's silver chloride, from 17 grams of silver nitrate, reacting with an excess of barium chloride. So now, again, this part we can just kind of ignore for now. That's just saying we have lots of this reactant. Nothing's limiting. We'll be working with that later on in the year. So this part, for right now, this isn't important to us. But what's given is, we are given 17 grams of silver, that's Ag, nitrate, NO3. And now you're going to convert the grams into moles. Then once you have the moles of silver nitrate, we're going to take a look at the molar ratio. We got 2 moles of silver nitrate, and you got 2 moles of silver chloride, so we've got a 2 to 2, and it's just going to be just like we did in step 1. Let's take a look at step 5. How much barium chloride is necessary to react with silver nitrate in problem 4? Okay, so how much barium chloride is necessary to react with silver nitrate from problem 4? So we're looking for, this is what we're looking for, grams of barium chloride. In problem 4, when you get the calculation, when you figured out how many grams of silver chloride, that's going to become our given. We will take this over here, and that's going to be our given. I'll just put an arrow there. That's the given. So now we're going to be comparing silver chloride to barium chloride. And we find out that the ratio, there's 1 barium chloride for every 2 silver chlorides. So our ratio will, as you set it up, it'll either be 1/2, or if you have to set up the other way, it'll be 2/1. You just work that out as we did in the first one. So again, use number 1 as a guide. First off, the first part, just take it, break it in little spots. You're converting into moles. Once you've got this part here, now then, the second step, we've got moles. You're converting it using ratios, mole-mole conversions. You're finding out how many moles of another element, compound you have, in this case potassium chloride. Once these cancel out, we would have moles of potassium chloride, and now we're just doing moles into grams like we've done before. So now we're just taking 3 one-step conversion process and just sticking them together into the end project. I don't want you to do 3 separate ones. That's bad. That's bad formatting, bad practice. You need to get setting up like this, and you will not get them wrong unless you just can't do simple arithmetic. All right, I will stop now. This will be due Monday. You're going to have a few minutes to work on this, and then you can. Then we'll be seeing a video in a little bit. Bye.